Welcome to the Learning Lab. My name is Roman Garcia. What I'm going to show you today is just one example out of many that is happening on a daily basis throughout the medical community, and not only in where I live, which is South Florida, but really the whole world. I'm going to give you one case to exemplify this what is happening nowadays in our medical centers that specializes in joint problems. Now, this case that I'm going to present to you is a classic example of physicians overthinking a condition or not having the correct amount, quality, and quantity of data in order to come up with a proper diagnosis. This is one particular case that we saw from a gentleman who came from Sweden with a diagnosis that, to be honest with you, I even had to go to the internet to know what exactly it was, because I had never heard of this diagnosis. This patient came to us with this diagnosis, and he came to us using crutches, because the physicians, the ortho physicians in Sweden, recommended that he had to be under a weight-bearing constraint. So he was using bilateral crutches. Now, the interesting thing about this patient is that he had no pain. His only symptoms was a generalized weakness in both legs and a heaviness in his knees. He was examined in Switzerland. And basically, the only examination that they did was a quick evaluation, physical evaluation according to the patient, and they did an MRI. Their diagnosis was basically based on the MRI results, and the diagnosis that he was given was this. This is a diagnosis he came with, based on visual data, which was the MRI. The diagnosis was Albach disease. That was the diagnosis this patient from Switzerland came with. Now, as I understand it, the medical industry in Switzerland is very advanced, and they got, according to them, one of the top-rated medical institution that there is in the world. So Switzerland doctors are top-rate. At least that's what I keep hearing. But this gentleman was diagnosed with this condition. Where again, I had to go into the internet to find out exactly what it was. And what it is a spontaneous osteonecrosis of the femoral condyle. Now, osteonecrosis, all that is a deterioration of the bone tissue as time goes by. And it can be diagnosed many ways. It can be diagnosed with an X-ray. It can be diagnosed with MRIs, which is what it was done in this particular case. But the interesting thing is that when we examined him, he didn't show any of the typical characteristics of osteonecrosis in the knee. And I'm going to share with you his examination. Now, this is the examination. And this is pretty much the quick summary of what I found when we examined him. He had the examination, his knees physically, when I examined him palpation-wise, and the physical examination didn't really reveal a knee that was under duress, or at least not too much under duress. The right knee was more involved than the left. The right knee had some stress converging, or some stress accumulated on the medial compartment, on the inside of the knee. The right knee had a little bit of biomechanical flaw, only 3 degrees. That wasn't much. The left knee was completely normal. Biomechanically, the left knee was completely normal. He had a little bit of congestion, again, on the right medial compartment. There was none on the left knee. So in essence, this patient showed a right knee that was under a little bit duress on the right, but had no duress, no physical signs of duress on the left knee. Now, the interesting thing about this patient is that he came with an obvious neurodegenerative condition. The gentleman had tremors, and his speech was not normal. It was somewhat slurred. So I made these notes when I examined him. I wanted the possibility of ALS, the possibilities of myasthenia gravis, the possibilities of multiple sclerosis, or even the possibilities of an unusual type of Parkinson's. This is the impression this gentleman gave me. I was actually more concerned with the possibility of a neurodegenerative condition than a joint condition. But again, the examination continued. We treated him as a case of osteoarthritis because, again, the physical examination did not reveal any type of osteonecrosis possibilities, nor did the x-rays. And I'm going to show the x-rays to you. Now, before I show you the x-rays, what I want to do is I want to give you, I'm not going to go through it completely, but I'm just going to give you a little bit of a taste of a principle that was discovered decades ago in the early 1900s, and possibly even earlier than that. Now, long time ago, it was discovered that whenever a mass is moving, there is a unique properties to a mass when it's in a moving state. There is conservation of energy. Now, all living things, they move. Now, when a body that has mass is moving at a certain velocity, it takes energy for that mass to move. Now, that energy is depicted in the actual action of motion. So that energy that goes into moving this mass is conserved. But no, the human body is not 100% efficient as no moving mass is. There's always some loss of energy that goes into moving the mass. Now, this idea was actually formulated into a mathematical formula that even to this day is used in order to predict celestial motion. But we use it in our facility as an idea of this conservation of energy whenever a mass or a person is moving from point A to point B. I'm going to show you the mathematical formula, but it's really not important for you to understand what this formula means. I'm just going to go through it real quickly. And then you'll understand why I'm presenting you with this idea, this principle. Now, this principle, the quantity of this formula, the discoverer of the conservation of energy gave it a name, which is vis viva. Vis viva is Latin for life's energy, and that's basically what the name that they gave the quantity of this formula. This variable right here, this stands for entropy. We've dealt with entropy before. The M, velocity, M is mass, and V is velocity. So M is mass, V is velocity. So entropy is equal to mass times square root of velocity. Now, again, you don't have to worry or try to understand what this formula is. The point is that when we move from point A to point B, there is always a loss of energy, and it is this loss of energy that determines what the probabilities of you developing degenerative changes, especially in the knee. The less loss of energy that a human body, a person, experiences, the least the probabilities of you experiencing degenerative changes in your knee. This gentleman, I believe that this gentleman, because of his neurodegenerative condition, he was losing tremendous amounts of energy as entropy. Energy in this formula, the energy, this entropy, in essence, is thermal energy. Is thermal. So, the more energy you lose, all that means, we can describe it as the more energy you lose, the more heat energy you produce. Heat is not a very efficient energy. Heat, in essence, becomes the amount of stress that you are exposing your joints to. So the higher your thermal energy that you produce, the greater the probability that you're going to develop degenerative changes. In essence, so the loss of energy means you're producing more heat energy. That's why activities that incur tremendous amounts of physical demand generate more heat, because as you're moving the body at high levels of stresses, you're producing greater loss of usable energy. Thus, you're producing more thermal energy. That thermal energy creates havoc, chaos inside the joint itself, and thus it produces what we call osteoarthritis. So in essence, when this gentleman from Sweden, when he would walk, his walk was very labored. It took a lot of energy for him to go from point A to point B because of his underlying undiagnosed neurodegenerative condition. So what the physicians saw in Sweden when they did the MRI was, in essence, this thermal energy inside the bone tissue itself, and they deduced it as a osteonecrotic condition evolving in the bone, when in reality it wasn't. What this individual in essence had was a simple degenerative condition, osteoarthritis, developing in the knee because he was not efficient when he was moving from point A to point B because of neurodegenerative condition. Now I'm going to show you an actual x-ray of an osteonecrotic joint, and then I'm going to show you his x-ray so you can see with your own eyes the difference. And then I'm going to show you one of the easiest tests that you can do on yourself for you to be able to have some kind of insight as to how much energy you are losing in the form of heat when you are walking. This is a very sensitive test that you can do yourself in order for you to begin to understand what's happening in your joint, and it's extremely simple, and I see this over and over in the clinic. Now, what I'm going to show you first is the example of an osteonecrotic knee. Now, this is a true osteonecrosis. No. This is an osteonecrotic femoral condyle, which is what Abach disease is, and that's the diagnosis they gave this gentleman. This is not his x-ray. This is a picture from a medical website. Now you see this little black spot right over here. That is an osteonecrotic femoral condyle. The actual bone is actually deteriorating. The joint surface is not that involved. That's basically what osteonecrosis is, and that's the diagnosis that they gave this gentleman. He had osteonecrosis. This is a classic telltale sign of osteonecrosis. X-rays are very sensitive to osteonecrotic changes. It's very easy to see on an X-ray. So this is osteonecrosis right here. This is a true osteonecrosis, and we've seen it many times in the clinic. But this gentleman did not have this, and I'll show you now his x-ray. Which is the interesting thing, is why did they give this gentleman that? And the only reason I can figure is because these Swedish doctors didn't have enough data. They just did not have the data. They weren't thinking in terms of physics. Now, this is his x-ray right here. This is the left, this is the right. If you recall the earlier picture, you saw that little black spot. There's no black spot in this knee. Now, this knee shows that there's some degenerative conditions over here, but there's no osteonecrosis. It's just that this gentleman, when he's moving from point A to point B, he's expending a lot of wasteful thermal energy because of his neurodegenerative condition. So that is what you risk when you go to a center that has absolutely no idea how to evaluate a joint condition. Now, these are his biometrics. You can see that he's asymmetrical. One leg is going into valgus, the other leg is going into bowing. You can see these magnitude triangles right over here. This gentleman is a natural, this man is a natural knock knee, valgus individual. The right knee was more involved than the left. The lateral triangle is larger than the right. He relies more on the lateral compartment than he does on the medial. But again, he's asymmetrical. And again, this is his X-ray right over here. There's no signs of osteonecrosis. Again, he was misdiagnosed. Come over here. This gentleman was misdiagnosed. This gentleman was not given a correct diagnosis in Sweden. And the first thing we did with the gentleman is we removed his crutches because he didn't need to be in a non-weight-bearing or partial weight-bearing state. He could weight-bear on his knees. It's just that, again, his life energy was all on the positive. He was extruding thermal energies out into the environment. His entropy was higher than a normal individual that can move from point A to point B in a rolling fashion. This gentleman was flat-footed, so he was generating thermal energies, high thermal energies, wasteful energies, and it was reflected in the bone. So when they did the MRI, it looked as if he had osteonecrosis. Again, that's what happens when you go to a medical center that do not take all these variables into consideration. That's why they come to us, because we know what we're doing. Now, what I'm going to show you now is, for an individual, one of the easiest tests that you can do in order to detect if you're in this positive state where you're developing and you're basically throwing heat energy out into the environment, high energy environments, high heat energy out into the environment. It's a very easy test to perform, and I see this over and over again. But the interesting thing is that I detected on patients that already have degenerative changes in the knee, but I believe that even in those individuals who do not have pain in their knees yet, they will exhibit this particular sign if they do it. And this will give them a clue, an idea that they are indeed developing or are developing degenerative changes at a very high rate. They are not in a negative entropy state. They are not in a vis viva state which is conducive to healthy tissues. And I'm going to show you with my assistant, Anna. Okay?
Hi.
So Anna's going to lay down completely.
Hi, everybody.
She's going to lay down flat. And now, this is what you do. I'm going to do it, and this is what I noticed. This is the observation I've made over and over again. You can relax. The majority of my patients who come with knee problems, at a low level, high level, it really doesn't matter. Esta rodilla empuja para abajo contra mi mano. No, para abajo. Relájame. Relax. Again, push down. Relax. All right. Carlos, focus in right here. When you are in a state that you are producing low thermal energies out into the environment, one of the best tests that you can do, push down, empuja para abajo, mantiene. Look how her quads contract. Correct? Relax. Again, look how the quads contract, but the gluteals do not. Relax. Again, only the quads are contracting. Relax. When you're in a vis viva state that you are producing high thermal energies because you're not efficient going from point A to point B, you lose the ability to contract the quads. So when I ask a patient that is in a very high positive entropic state, they are not able to contract the quads. They try to do push down, empuja para abajo. They try to do this motion, push down against my hand, not by contracting the quads, but by contracting the gluteals. So if you do this test at home and you notice that you are not contracting the quads and you are contracting the gluteals, you know that you're in a positive entropic state. All the weight-bearing load when you're going from point A to point B are all converging on the actual joint tissues. The muscles are not dissipating that thermal energy. You're not efficient. You're not rolling. All your weight-bearing load is completely vertical. So they're all converging on the bone tissue, thus producing an environment that's conducive for damage to the joint itself. We're going to do it one more time. Empuja para abajo. You see the quads contract. That means that these quads, when Ana is going from point A to point B, these quads are active. And they are contributing to the biomechanics, the normal biomechanics of the joint itself. So she's not producing high thermal energies that are escaping out into the environment and staying inside the joint, destabilizing the joint tissue itself. That right there is one of the easiest tests that an individual can do in order to approximate, predict whether they are in a positive entropic state. Again, in order, what I'm showing you here are very advanced evaluation techniques and observations that have been made over years and documented. And these are not mystical. This viva is not a mystical principle. It is actually an idea. It's a principle that's backed up by mathematical formulas. So this is science-based. These evaluation techniques are science-based and have been supported by observations that occur over and over and over again, which is basically the fundamental basis of science is observations and able to make predictions based on multiple observations. Again, what I highly suggest is that whenever you have a joint problem, knee joint problem, any kind of problem, you need to go to a center that's science-based and are not only making diagnosis based on just one perspective. This patient from Sweden was given a diagnosis based on one perspective of the environment on an MRI exam and neglecting all the other variables involved in this particular case. This is one case. There are millions out there. Again, anybody who's watched this video, if you have knee problems and you want to get a correct diagnosis, you can contact me. Or you can contact me over the email. I leave my phone number on the videos. You're free to contact me and we can discuss what can be done about your condition. Again, anybody who's watching this video, I want to thank you. Until next time.